Hello everyone, and welcome to the pre-lab for explosions. Alright, although don't get too excited, we're doing this on Pivot, and they're not big old chemical explosions, they're explosions made by a compressed spring, so, but still, the same idea is there. Up till now, we've been kind of focusing on what goes on during the interaction, during the collision. Right? And we came up with a way of analyzing what happens during the collision by looking at the impulse change in momentum theorem. But now we're going to kind of look at what happens outside of a collision. And we're going to do this in a couple of stages, but we're going to start out with these little controlled explosions in our Pivot Interactive. So in the Pivot, you're going to see that you have two gliders on an air track. So it'll ride on a little cushion of air to reduce any frictional effects down to basically zero. And when you hit start, there's going to be a little compressed spring between the two gliders and a ribbon. And when the ribbon gets cut, the explosion happens, right? And the gliders travel off to the ends. And we can change one of the gliders. We can change the mass of one of the gliders, okay, within the Pivot Interactive. So basically here, the question we want to answer is, we want to know if there's a way to compare the momenta of the gliders after the explosion, right? How much momentum this one has versus that one. And in the Pivot, I just call this right and left, I guess, in the lab sheet, right? So the right glider versus the left glider. Okay? And so the purpose of this, again, if you look at your lab sheet, is to determine the relationship between the momenta of two gliders after an explosion. And is there a predictable pattern that we can come up with? Right? So we're going to do several of those in the Pivot, and in a moment I'll show you what the Pivot looks like. But a couple of things we need to talk about is, what are we going to need to measure in the Pivot to be able to satisfy our purpose, to compare the momenta of the two gliders after the explosion? Right? Well, remember, first of all, momentum is mass times velocity. So we're going to need to be able to measure the mass and the velocity of each one of these gliders in order to be able to calculate the momentum, which we can then compare. Okay? Now, mass is just given to you right in the Pivot. It's actually one of the things you choose. Okay? In the Pivot is the mass of each glider. Velocity, we have to get a little more clever here. Now, Pivot Interactives don't measure velocities directly. We don't have some fancy Bluetooth motion detector or encoder wheel or something like that. Okay? So what we need to realize is that after the explosion, okay, because there is no friction, because the gliders are on an air track and are riding on a little cushion of air, okay, and it's been perfectly leveled off, okay, we don't have to worry about any frictional effects. So once the explosion is over, the carts are just going to move at a constant velocity, or a constant speed, I should say. Right? And we know how to calculate a constant speed. It's just distance over time. So within the Pivot, we need to measure each glider a distance that it moves and divide it by the time that it takes. And I'll show you how to do that momentarily. Okay? Now, we do need to be a little careful when you go to record these, all right, is that eventually we're talking about vector quantities here for momentum. And we're going to talk about, therefore, velocity as a vector, right? And momentum as vectors. Now, the Pivot isn't smart enough to do that, right? So we'll calculate a speed, but then when we go to put directions in, since this is one-dimensional, okay, we just need to use the conventional one-dimensional to the right is positive and moving to the left is negative. So we can put some positive and negatives into your data sheet. Okay, and just by watching the video, and then you'll have vectors as opposed to scalars in order to compare your momenta. Okay, so now what I'm going to do is I'm going to show you the Pivot Interactive. Links for the Pivot as well as the lab sheet are, of course, on your schedule page. Hello, everyone. So here's the video for explosions, right here. Couple things about it. It's inside of the Pivot, right, that you're doing, which is explosions. Not really. They're physics explosions. Here, just watch the video. Ooh, there's our explosion. That noise you heard, by the way, was the compressed air going through the air track. You don't really need the sound. You can always turn that off. So some things you need to know about the Pivot. First off, down here where you hit change, right? This is where you can change the mass of the gliders. Okay, you'll notice that there's not a lot of choices here, so we don't have a ton of trials to do, which is nice in some ways, not so nice in other ways. All right, not really easy to see a pattern with only a few trials, but they start out, it defaults to having them being exactly the same mass. You can also make this one twice as massive or 4 times as massive as the other one. Right, 140, 560. I'm going to choose the 280 here just as an example. When you do this and you go to change this, you have to hit load, and then notice it loads a new video. See how this is a much bigger, therefore more massive glider than this one? Okay. Up here is the tools that you can use inside of this. There's basically 3. There's 2 rulers and a stopwatch. Okay, so we take one ruler, we can move it around, grab it and move it. Personally, I would put this at the very edge of this glider, as close to the edge as I could get it. Right? So I'm using the front edge of the glider all the time. Right? I'd take this one and do the same thing. There we go. All right. The other one is a stopwatch, which you can grab up here. And remember that this tells you how many frames. It tells you that this is recording at 120 frames per second. So every frame is a 120th of a second. Very high speed, right? And this is the reset button, remember? So I might go to a point where, okay, I don't want while the spring, all right, is expanding, because then it's putting a force on and it's changing the motion of it. Right? It's making the gliders accelerate. I want it just after the interaction is over. So maybe here. Okay. Now I do have to reset my rulers. So that's going to be my 0 now. Okay. And then I can hit reset. See how it now put it to 0. And then I can run it, get it to where it's gone 30, or as close as I can. I'd say that's probably pretty good. Right? And then that means the left glider has moved 30 in 0.5333 seconds. Go a little further. I could either run it. There we go. So now there's the right glider has gone 30 centimeters in 1.0667 seconds. And with that distance and that time, I can figure out a speed, because if you notice, these are basically moving at constant speed once they are released from the spring, right? Once the spring stops acting on them. We could probably neglect air resistance effects. It's perfectly leveled, and because it's riding on a little cushion of air, no friction. So watch again. You see how they just move constantly that whole time. Those are really the only measurements you need to make in this whole video. Okay, so the reset button here will help. Right, you set it to 0 just after, right, the spring goes away. Of course, don't forget this button down here, which would make it full screen so that you can make it bigger and see it a little better. Okay. So there we go. Hope you do well on this explosions activity.